In this video, we're going to use Python to identify the GDP gap. So if you're following along in the Python workbook, go to drstephpowers.github.io/econ in Python. That's econ-in-Python. And we're working from the workbook called GDP Gap. So click on that and it takes you into GitHub. Once you are in GitHub, you will want to open in Google Colab. So click on that little button on the top. In order to run the code, you will need to be logged into your Google account, so make sure you sign in. And in order to edit the code, you need to make your own copy, so make sure you copy it to your drive, and then you can save it, do whatever you want with it. All right, so what we're going to do is we want to take this information here, and we want to plot aggregate demand and aggregate supply. And when we look at aggregate demand and aggregate supply, it is about plotting real GDP, the total value that everyone wants to buy of the goods and services, versus a measure of their price. So the consumer price index or some kind of measure in inflation. And that will give us aggregate demand. Then we plot real GDP in terms of the amount that businesses will produce relative to the different prices or CPI. So here we have three columns of data. We have our price index, we have our quantity demanded, which is aggregate, so it's everyone who's buying goods and services in this economy, and we know that comes from aggregate expenditures. So this comes from consumption spending, that's households, plus investment spending, that's businesses, plus government spending, plus export spending, that's people in other countries buying our stuff, minus import spending when we buy from other countries. So that's where that aggregate demand comes from. And then the aggregate supply comes from our businesses making goods and services. So let's start by plotting this information in Python. And so I'm just going to switch from here, where I'm not logged in, to the version where I am signed into my Google account and I have a copy. All right, so anytime we want to graph in Python, we need matplotlib.pyplot. That's the package we're using. And to make life simple, we just call it PLT. We're also going to be manipulating our data, so we're going to use NumPy. And to make life simple, we'll call it NP. So the first thing we want to do is import our packages. The next thing we want to do is dump in our data. So we're simply taking that information that we just saw here on this screen. So just go back. So you see that column, price index, aggregate quantity demanded, aggregate quantity supplied. And so I can simply type that in by doing CPI. So I just need a name for my price index. And then here are the numbers in the same order as you saw on the table. And I put that into Python. And now I'm going to do the aggregate quantity demanded. And so I'll call that AD because ultimately it'll become our aggregate demand curve. And again, I'm just entering it in the order that it appeared on the table. So just to flash back, you can see when the price index is 96, aggregate quantity demanded is 1145. And as the price index increases, so we get more inflation, people can't afford to buy as much stuff. And so our quantity demanded here, measured in real GDP, is going down. So if I go back, you can see here it follows that same order, 1145 to 965. I also want to plot aggregate quantity supplied, which will become the aggregate supply curve. And so I enter the data in, just like I do with the other ones. And so you can see here when the price index is 96, businesses aren't willing and able to sell as much, less of a profit margin at lower prices. And as the price increases, ceteris paribus, so everything else held constant, the only thing that's increasing is price, they're willing and able to sell more. That's increasing the real GDP, total quantity of all the goods, total value of all the goods and services, taking out inflation, increases. So we can see that the aggregate quantity supply goes from 880 to 1045. And so we can see 880 to 1045, and I dump that into the system. So what we're going to do next is graph it. Let's graph aggregate demand, aggregate supply, and find that equilibrium size of the economy. So we are using plt.plot. Whatever goes on the horizontal axes is going to go first in your code, and then whatever's on the vertical axis goes next. We're going to have it marked with dots. We're going to plot aggregate demand and aggregate supply on the same graph. So I got two rows here that tell it to plot. And then I can label the x-axis, that's the horizontal, as real GDP. And I can label the vertical axis as CPI, or some measure of inflation. We could call it price index or something. To make life easier, we add a grid and then we tell it to show the graph. So we hit run and we get a graph that looks like this. We have our downward sloping aggregate demand curve because, again, at higher prices, people can't afford as many goods and services, so a high inflation is a lower real GDP. And when things are cheaper, everyone can afford to buy more. We have an upward sloping aggregate supply curve. Notice it's not a straight line, and you can refer to the other videos as to why that is the case. And we have it upward sloping though because as the price goes up, as there's more inflation, businesses can charge more money, and ceteris paribus, holding everything else constant, at higher prices they make more profit, and so they're willing and able to sell more, and so we get this upward sloping aggregate supply curve. We can see that equilibrium happens right here. So that happens at a CPI of 102. A CPI of 102 tells us what? It tells us that there's been 2% inflation since the base year, because remember the base year has a CPI of 100. So if the base year was, let's say it was 2020, and now we have CPI of 102, there's been 2% inflation since 2020. Okay, so it's important to know what that base year is as a comparison, but a CPI of 102 simply tells you how much inflation since the base year, comparing it to 100, so 2% inflation. And at that CPI, what we have here is we have an equilibrium economy at 1025. So the size of the economy here is real GDP of 1025, and we have inflation that's 2% compared to the base year. Now, we said this video is about identifying the GDP gap. Are we in is our economy expanding? Is it contracting? So do we have an inflationary gap due to expansion, so also called an expansionary gap? Or do we have a recessionary gap? The economy is contracting. So in order to identify this, we need one more piece on our graph. We need something called potential GDP. Potential GDP is how big the economy could be if it utilized all of its resources. So that comes down to those factors of production. If it used all of its land, its labor, its capital, its enterprise. And often we focus on the labor part. So if we're at the natural rate of unemployment, okay, so the unemployment rate doesn't have any cyclical unemployment, so we're at the natural rate, then we're considered to be using all of that labor, we're at full employment. So we want to be able to identify what potential GDP is compared to where we actually are right here at 1025. So we need to add one more piece to our graph. So let's suppose that potential GDP is at 1025. So this line of code that you see here says, let's call it potential, P-O-T. We can call it whatever you want. And we're going to use that NumPy package, so that's the NP. And we're going to repeat the number 1025, and we're going to repeat it for the length of CPI. So up here, we had CPI, and you'll notice that CPI has 3, 6, 9, 10 numbers. So if we repeat 1025 for the length of CPI, we're repeating the number 1025 10 times. So that's what that code means. And you can see it here if you just type in POT. Capitalization matters. If you're doing this, it needs to match. But you can see here that it's 1025 10 times. Well, why do we do that? That's because potential GDP does not depend on inflation. Potential GDP is the size of the economy if we utilized all our resources, all of our land, labor, capital, and enterprise. It is not dependent on inflation, so potential GDP being graphed is a vertical line. So let's actually add that line to our graph. So you'll notice the code is the same as before. We're going to plot aggregate demand. The real GDP goes on the horizontal, CPI on the vertical. We're going to plot aggregate supply. Aggregate supply here goes first, then CPI. And let's add in this line of code here, that is plt.plot. Okay, so we're going to plot the data. let's plot the potential GDP relative to CPI. And you'll notice that potential GDP, right, was 1025, 10 times. And so when we do that, we're going to plot just a vertical line at 1025. So it's not dependent on inflation. And to note that this is different from demand and supply, let's not have it be dots. So let's remove the marker and let's make the line style dashed. Okay, the rest of it you notice is the same, real GDP on the horizontal, CPI on the vertical, and we add the grid lines. So we run our graph, and what this shows us here is this shows that we are at full employment equilibrium. Full employment equilibrium means we have no GDP gap, no expansionary or inflationary gap, no recessionary gap, okay, or contractionary gap. So we're at full employment equilibrium. And you can see that because the potential GDP, this vertical green line, goes through where we actually are at that 1025 equilibrium. Well, what if potential GDP is not at 1025? So let's try a scenario where our potential GDP is 1040. So we're going to redefine potential GDP as repeating the number 1040 for the length of CPI. So I run that, okay? And now if I go in and redo my plot, so I just rerun the code because I've redefined what potential GDP is. Notice now that green vertical line has shifted to 1040. So our potential GDP is here. Our actual GDP is here at 1025. So now we have a gap between 1025 and 1040. Okay, 1040 minus 1025 is the size of the gap. Okay. So how big is that gap? 1040 minus 1025. You make me do math in my head. What is that? 15? Okay. So we have a gap of 15 in terms of real GDP. That's this horizontal difference here. And then the question becomes, what type of gap is that? Well, if potential is bigger than actual, then we are not at our potential. We are not using all of our land, labor, capital, and enterprise, which means we have unemployed, cyclical unemployment, which means our economy is contracting, and so we have that recessionary gap. Okay, so we're not as big as we could be. Now, if we instead define potential GDP by repeating the number 985 for the length of CPI, so let's run that. And then we redo our graph. So we don't have to change the code, we just have to rerun it because we've changed what the numbers are for potential. And notice now that that potential GDP is now, what did we make it, 985, and our actual is at 1025. So notice there is a gap between 985 and 1025. Okay, so how do we figure out what the size of that gap is? Well, we can take 1025 and subtract 985 and get the size of the gap. It's that horizontal difference here. And what type of gap do we have? Well, if this is actual and actual is more than potential, then that means we have an expansionary or inflationary gap. We are bigger than we would be if we utilized all of our land, labor, capital, and enterprise. Well, how do you get there? How do you get to an expansionary gap? You're bringing in foreign workers. You're paying everybody overtime. People are working extra shifts. And that's an economy that's really not sustainable because you can't find enough workers for the jobs that are available. And so we want to be able to compare that potential and that actual. And what we want to do as we start to talk about monetary policy and fiscal policy is we want to talk about how we close the gap. And that brings us back to our discussion about supply-siders in terms of the schools of economic thought, Keynesians in terms of that school of thought, because how you close these gaps depends on whether you're focusing on shifting the demand curve. So right here, we could fight inflation by decreasing demand, which would shift the graph down here to close the gap. So you would need demand to go down. Okay, well, how do you get people to buy less stuff? Monetary policy says raise interest rates. If you are trying to change people's demand and you're using fiscal policy, we're raising taxes, we're lowering government spending to get that under control. So monetary and fiscal policy will have different approaches to demand. Keynesian and supply siders will have different approaches. The supply sider focuses on the supply curve, the demand focuses on the demand curve. So for example, if we go back to our gap here, the supply sider would focus on increasing supply, shifting the curve to the right to close the gap, so we end up back here on that potential GDP. Well, how do you increase supply? You lower taxes to businesses, you create incentives for businesses to produce and expand. If you are a Keynesian, you would focus on shifting the demand curve. You would want to get demand shifted to the right, increase demand, get us back to that equilibrium here, back on that green dotted line. And how do you increase demand? Well, we increase government spending, prime the pump, put more money into people's pockets so they buy more stuff. So we want to be able to graph demand and supply for the overall economy, so aggregate demand and aggregate supply. And then we want to be able to find out what type of GDP gap we have so that we can then figure out what is the appropriate policy, monetary, fiscal policy, what is the appropriate policy, whether we're a supply sider or a Keynesian, to help resolve the issue. The gaps are a problem, both gaps. One causes too much inflation. We can't find enough workers to sustain the demand for goods and services. The other one is we don't have enough jobs. We don't have enough demand for goods and services. People aren't making enough income. Businesses aren't hiring people. There's a lot of people unemployed. So both gaps are problematic. And so in economics, we try to resolve both of them.